Hey guys, you're ready to get started on our last leg of math lessons and videos for this year. You're almost done with your 8th grade year. You're almost a freshman. In this one, we're going to be talking about some more geometry information about volume and surface area and things like that. And we're going to start off lesson 1 with volume of cylinders. Okay? We're on page 589. I get asked all the time, where's my vocabulary? Where do I find my vocabulary? Well, you can find it at the beginning of the chapter. Oops, sorry about that. Let me get rid of that. You can find it at the beginning of the chapter. This happens to be on page 484. So look down here on page 484. That's the beginning of chapter 8. And the vocabulary is going to be in this box right up here. So if you ever need to go back and find your vocabulary, that's where you're going to find it at. Okay, so now let's go back to the page that we were just on. We're going to be talking about page number 589 about volume of cylinders. I'm going to go ahead and skip this first page just because the stuff on it, I understand what they're trying to say here, but I don't like the way that they have it laid out. So we're just going to get right into how to find the volume of a cylinder. Well, first of all, a cylinder is this shape right here. Any canned good, a Pringles can, things like that. Those are cylinders, okay? And a cylinder it's a three-dimensional figure, which means that it has length, width, and height. And it has two parallel congruent circles. Now let's think about that for a minute. Parallel means that they run side by side, they don't ever touch. And congruent means that they're the same shape, same size. So on the top and bottom, they have the same shape and same size of circles, okay? And we want to talk about volume. This is the equation that you're going to need for volume. Okay? You're going to take the radius, whatever the radius is. Remember, radius is half of the circle. You're going to take the radius, square it, and then take that times pi, and then take all of that times the height of the can or the height of the cylinder. Okay? So let's go down here and look at A. It says find the volume round to the nearest tenth. So we are going to find the volume of these cylinders. Let's look at this first one. This one is, the radius is 3. I don't have to do anything to that because it's already split in half. So half of the circle is 3, so my radius is 3. The height is how tall this is. So the height for this one happens to be 1.8. This is like a small, maybe a Petri dish would look like this. And I don't know if you've used Petri dishes in science, but they're those glass things that are flat and you put a lid on top of them. That's what this may look like, because it's pretty small. So in order to do that, I'm going to use my equation, and remember the equation for volume is pi times radius squared times height. Now, I will tell you that the pi, whenever they're doing this, they're not using 3.14. They're using the actual pi button. So on your calculator, you can't see that very well because of the light, but on your calculator, the pi button is going to be right down here. You're going to look somewhere for the pi sign. So in this one, I would have to hit Shift and then the scientific notation button. Okay? So let's do this one. So I have pi times radius squared. Well, my radius is 3, so now I have pi times 3 squared times my height, and my height is 1.8. So if I do that on my calculator, first I'm going to take 3 squared, so take 3. Let me turn off my light and see if that helps. Take 3, then I'm going to square it, which is right here. So 3 squared is 9. 3 times 3 is 9. Then I'm going to take that times, so I'm going to hit times pi, and remember pi is Shift, and then the scientific notation button, which is right down here. So here is what I get when I take pi times the radius squared. I get 28.274333388, and then I take that times the height. The height is 1.8. Okay? So when I do that, I get 50.8938. I'm going to write all that down here real quick. When I did this one, I got 50. Let me look at my calculator again. 89.3800099. Now, the directions say round to the nearest tenth. Well, hopefully, you know that the tenth is this place right here. It's the first one past the decimal point. So I'm going to round this 8. I'm either going to leave it an 8 or I'm going to round up to 9. And how I decide that is this one right behind it. So this 9, if this is a 5 or above, I'm going to round up to the next number. If it's below 5, I'm going to leave it an 8. Well, this one is a 5 or above, it's a 9. So I'm going to round up to the next number. So this actually becomes 50.9. And don't forget your unit, it's inches. How many numbers did I multiply together? I multiplied 1, pi was 1, 2, 3 numbers, so volume is always cubed. Okay? All right, let's look at B. B says I have a diameter of 12. Well, I don't want diameter, I want radius, but we'll talk about that here in just a minute. And the height is 5. Okay? So if I have my diameter, the diameter is all the way across the circle. If I want halfway across the circle, I would have to take my diameter divided by 2. So hopefully you know that the 12 divided by 2, or my radius, is 6. So again, here's my equation. My equation or my formula is volume equals pi times radius squared times height. My radius is 6, so I have pi times 6 squared times my height. It tells me my height is 5 millimeters times 5. So now I have 6 squared. 6 times 6, hopefully you know, is 36. So I have 36 times pi, remember shift, down here at the scientific notation button. That's my pi button. That gives me 113 point blah, 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 blah. And then I take that times the height, which is 5. So I end up with 565.48667776. And I want to the nearest tenth. Again, that's what the directions say, round to the nearest tenth. So again, hopefully you know that the tenth is this 4 right here. I'm either going to leave it a 4 or I'm going to round it up to a 5. And I decide by the number right behind it. If that number is above 5, then I round up. If it's below 5, then I leave it a 4. Well, this is above 5. 8 is higher than 5. It's a bigger number than 5, so I make this a 5. So I have 565.5. And then my units are millimeters. And again, how many numbers did I multiply together? 1, 2, 3, so it's always cubed. Okay? Let's look over here. This is talking about the Roberts family. Okay? For all of you Robertses out there, I'm sure this is talking exactly about your family. But it says the family uses a container shaped like a cylinder to recycle aluminum cans. So it's going to look like a trash can. Okay? So I have my trash can that looks something like this. Oops, let me connect that a little better. So here's my trash can, okay? And it says the height of the trash can, or the height of the recycling bin, because I didn't really call it a trash can, I said it's used to recycle, is 4 foot. And the diameter is 1.5 feet. So from here to here is 1.5 feet. Okay? How much do the contents weigh if the average aluminum can is 37 ounces? Okay, first of all, we need to find the cubic feet. When it asks for cubic foot, that's asking for the volume. Okay, so first we have to find the cubic foot, or the volume of it. So my equation for volume, hopefully you remember, is volume equals pi times radius squared times height. My diameter, it told me, was 1.5. I don't want my diameter, I want the radius. So I want halfway across here. I don't want all the way across there, so I have to take 1.5 divided by 2 to get my radius. So my radius is 0.75. That's the measurement I have to have in order to do this calculation. And the height, it told me, was 4 feet. Okay? So what I'm actually doing is I am taking pi times 0.75 squared times 4, because it's pi times radius squared, my radius was 0.75, times 4, my height. So if I take 0.75 squared, I get this. Okay, now I take that times pi, and I get this, and then I take that times 4. So it's 7.068583,471. And let me see, it says round to the nearest tenth. Okay, so I can do that. Nearest tenth is this 0 right here. I'm either going to leave it as 0 or I'm going to round up to a 1. Because this is a 6, I'm going to round up to 1. So I have 7.1 cubic feet. Now it says that the cans weigh this many ounces per cubic feet. Hopefully you remember the word per means to multiply. So I'm going to take this times however many cubic feet I have, and now I know because I found the volume I have 7.1. So you're going to take 37 times your volume, which is 7.1, and that's how much it weighs, 262.7. It says how much does the contents weigh? Well, we are talking about ounces, so it weighs 262.7 ounces. Okay? All right, let's go on to the next one. Now we're talking about composite solids, and composite solids are a little more complicated in that they contain more than one shape. So for instance, this one, they're talking about a bead, and if you've ever worked with beads, you know that there's usually a hole that runs through the middle of it for you to string the line through, or to string whatever it is that you are putting the beads on. So this is a square bead, and they want you to take out this volume of the inside hole, okay? So let's do an example like that. Here's another composite figure because it's a rectangle, and on top of that rectangle is a half of a cylinder. So I actually have two shapes. I have a rectangle, and then I have half a cylinder that I have to worry about, okay? To find a rectangle, to find the volume of a rectangle, you just take the three measurements together, length times width times height. Okay, so here are my measurements. This is my three measurements for this rectangular solid. My length is 50. My width is 25. And my height is 30. I just take those three together to measure it, to do the measurement. So I have 50 times 30 times 25. And because I'm multiplying, it doesn't matter which order I put them in, but I get 37,500. Now I have to add this half of a cylinder to it. If I looked at the cylinder, well, how tall it is going to be the same as the length of the rectangle. So my height for that cylinder is going to be 50. The diameter of the circle, if this were to complete the circle, this part right here would be my diameter, which is the same as the width of the rectangle. So my diameter is 25. Now remember, when you're finding volume for a cylinder, you don't want the diameter, you want the radius. So I would have to take 25 divided by 2, which gives me 12.5. So the radius would be 12.5. So here's one of my volumes. That's the volume of the rectangle. I've taken care of that. Now I need the volume of this half a cylinder. To do the volume of a cylinder, that's what we've been doing. You take volume equals pi times the radius squared times height. The radius is 12.5, so it'd be pi times 12.5 squared times my height of, it tells me right here, the height is 50. So I'm going to multiply those together. So 12.5 squared times pi times 50. So if this were an entire cylinder, it would be 24,543 and we're going to round to the nearest tenth. So hopefully you know that means I'm going to leave this as 6, so I'm going to round up to a 7. Because this is a 9, I'm going to round up to the 7. So if this were an entire cylinder, that's what this would be. But it's not an entire cylinder. I don't have a can sitting on top of this box. I have half of a cylinder sitting on top of it. So now I have to take this number divided by 2. So this part right here is 12,271.8, and I have to add this one to this one because that's what they are combined. So I take 12,271.8 plus 37,500, and together I have 49,771.8 centimeters cubed. Okay? So I took the volume of the rectangle, I added the volume of this half a cylinder, and together they have this volume. Okay? Now let's talk about something else. Let's say that I had, I'm just going to use this blank sheet of paper here. Let's say that I have a 3x5 note card. Okay, so I'm going to draw my 3x5 note card. That's what a standard note card is. It's 3 inches by 5 inches. Now let's say that I folded it. If I took the note card, and I don't think I have one right here handy. This will work. Let's say that I took the note card and I folded it hamburger-wise and made a cylinder out of it. Okay? So if I folded it hamburger-wise, this 5 is still up here, so that's my radius. This 3 is still how tall it is. And I want to compare that to if I folded it hot dog-wise, if I put it together hot dog-wise, which means I took the long ends and I put them together. Well, if I did it hot dog-wise, then this would be 3, and this would be 5. See what I'm talking about? This was the top of the card if I folded hamburger-wise. This is the top of the cylinder if I folded hot dog way. And I want to know which one has a higher volume. Well, if I took this, the volume doesn't change. It's still pi r squared h. So if I did this one, this would be pi times 5 squared times 3. This one would be pi times 3 squared times 5. And if I did both of those calculations, well, this first one, if I take 5 squared, 5 times 5 is 25, and I take 25 times pi, and then I take that times 3, I get 235, and we're going to go to the nearest tenth again, 0.6. Now if I did this one, just folding it hot dog way, does it change that? Well, 3 times 3 is 9, so already I know that 3 squared is smaller than 5 squared, so I think that's going to change it, times pi, so 9 times pi times 5 equals 141.4. So even though they were the same shape to begin with, the one with a larger radius, oh, you know what I did? I made a mistake here. This is my diameter. See, I just went back and checked that. My diameter was 5, and that's what I used in here. I don't want to use diameter. I want to use radius. So I have to take my diameter divided by 2. So 5 divided by 2 is 2.5. I'm sorry, that was my mistake, and 1.5. So let's do that again. So now I have 2.5 squared times pi times 3. And this one is 58.9. That's much better. So this one would be 58.9, because remember the diameter, you don't want the diameter, you want the radius, so you have to divide by 2. This one is 1.5 squared times pi times 5, and you get 35.3. We still know that this one is smaller because my radius is smaller, but now I've actually proven that because this one can hold 58.9 inches of stuff. This one can hold 35.3 inches of stuff. So just changing the orientation changed that. Okay? All right, guys, if you have any other questions, come in and feel free to ask us. Otherwise, I will see you tomorrow. Have a great night.